Hi guys, it's Mrs. Allison. Today we are going to finish up our factoring unit by looking at a method called factor by grouping. Now, factor by grouping is a method that is best used or most useful when you have four terms. So if we have four terms, or anytime you see a polynomial with four terms, probably one of the first things you want to think about is factor by grouping. So let's go through the steps to factor by grouping. And then let's try a few examples. Okay, the first step, the most important step when factoring any problem. It's been the number one step for every type of factoring we've looked at so far is to do what? We need to factor out the GCF. So if there is a greatest common factor in all four terms, that needs to come out first. So that's the most important step in all factoring. Then what we're going to do that's different is we are going to group the first two terms and the last two terms. And we're going to take the signs with them. So we're going to group our first two terms and we're going to group our last two terms and we're going to take the signs with those terms. That's why it's called factor by grouping. So the first step is to group first two and group the last two. Then what we're going to do is from each group, we are going to factor out the GCF. So there may not have been a GCF between all four terms, but there's going to be, or there should be, a greatest common factor in each group. Now, if there is not a greatest common factor in each group, then we cannot use this method. But our job today is to see how we can use this method, so all of ours will actually factor by grouping. Now, what we should see once we factor out the GCF from each group, and this is important that this is from each group, not from all four terms, whereas the first step is from all four terms. But what we should see from each group is that the remaining binomial, remember a binomial is two terms, should be the same for both groups. And then what we're going to do is we're going to factor out the common binomial. Okay, let's look at an example. And you know that I like color, so I'm going to do this in multiple colors just so you can see each group and each step, and it will hopefully kind of help you to see this process through. So the first thing I want to do is look at my term. I have x cubed 6x squared minus 5x minus 30. 1, 2, 3, 4 terms. So I know this is going to be a factor by grouping. The next thing I'm going to look for is a greatest common factor in all four terms. Well, there's not an x in every term, nor is there a number that goes into 1, 6, 5, and 30 other than 1. So I actually don't have a greatest common factor between all four terms. So now what I'm going to do is I'm going to group my first two terms together, and I'll do that in red. So I'm going to group my first two terms. Notice I'm taking the signs that go with those terms. Then I'm going to group my last two terms, and notice I'm taking the signs with those terms. Now you'll notice I've tricked for factoring out the greatest common factor of all four. I've grouped the first two terms and the last two terms, taking the signs with them. Now what I'm going to do is from each group, so from the red group and from the green group, independently, I'm going to factor out the greatest common factor. So let's start with that red grouping. Between x cubed and 6x squared, what is the greatest common factor? Well, my greatest common factor is x squared, and what that leaves me with is x plus 6. Now, in the green grouping, between negative 5x and negative 30, my greatest common factor is negative 5. They both have a negative 5, and I am going to take my sign and I'll show you why. And what that leaves me with is x plus 6. Because if I were to multiply negative 5 into x, I would get negative 5x. And negative 5 into positive 6, I'm going to get negative 30. The reason I chose to take my negative out is because the next step, step 4, says that the remaining binomials, that should have an S, binomials, should be the same for both groups. Meaning my goal is to get this binomial, the remaining, this binomial, the remaining, for each group to be the same. So I know this is x plus 6 and x plus 6, those are the same. So that x plus 6 is going to come out in front because they both have an x plus 6. And what I'm left with is the x squared minus 5. So my final answer is x plus 6 times x squared minus 5. If we were to check our work on this, so let's do that really quick. If we were to check our work, and I multiply x plus 6 times x squared minus 5, whether you use the box method, whether you use the double distribute or the FOIL, I'm going to use the double distribute in this case. So I'll do x times x squared, x times 5, that'd be negative 5, sorry, positive 6 times x squared, positive 6 times negative 5. And although it's in a slightly different order at the moment, if I were to write this in standard form, I would end up with x cubed plus 6x squared minus 5x minus 30. So because I can check my work and it equals the original problem, I know I have factored correctly. So that is factor by grouping. So I would love for you to hit pause and try the next example. All right, let's look at this together. And again, I'm going to use my colors. So I'm going to check to make sure that out of all 4 terms, there is no greatest common factor. Well, there's not an x in all 4 terms, and nothing goes into 3, 2, 12, and 8 other than 1. So now I'm going to factor out, or I'm going to group my first 2 terms taking the signs, and my last 2 terms taking the signs. And now I'm going to work with each group. In my red group, I can take out an x squared, and I'm left with 3x plus 2. In my green group, I can take out a 4, and it would be positive 4, and I'm left with 3x plus 2. Remember, the whole point of this is that those 2 binomials that are left over are the same, because then they come out, I'm just going to do this all in blue, so they come out as 3x plus 2, that's that factor that they had in common, and what I'm left with are the 2 terms left over, x squared plus 4. And so once I check my work, I know that this is my answer. All right, so if you didn't quite get that one, hit pause now and see if you can get it with the final example. All right, here we go. Final example. Let's see what we've got. So first thing I'm going to do is check to make sure there isn't a GCF for all 4 terms. I have a 5x cubed, a 10x squared, a negative 7x, and a negative 14, and there are no like terms. So the next step is I'm going to group my first 2 taking the signs, group my second 2 taking the signs. In the first 2 terms, I can take out a 5x squared, and it leaves me with x plus 2. And in the second group, the green group, I can take out a negative 7, and it leaves me with x plus 2. Remember, the whole point is that these 2 need to be the same so that I can factor those out front. So I'm taking that as my greatest common factor, and I'm left with the 2 terms that I pulled that out from. So the 5x squared minus 7. How'd you do? Okay, that's factoring by grouping. Now, I said we would look at other methods besides the Xbox for factoring trinomials where a is greater than 1. Let's look at how we can use factoring by grouping to factor trinomials too. To use factoring by grouping for trinomials, and remember we said factoring by grouping works best with 4 terms, we need to actually create 4 terms. So the start of this problem is really not going to be any different than before. We're going to first check to make sure that there are no greatest common factors between all 3. And I don't see any. The next thing we're going to do is we are going to start the idea of a box and remember or the x factoring. And remember in the x factoring, we looked for 2 numbers that multiplied to 4 times 3, a times c. So I'm looking for 2 numbers that multiply to 12. And those same 2 numbers need to add to be 7. So the numbers that multiply to 12 and add to 7 are in fact 4 and 3. So now what we do is we're going to take our trinomial and we're going to replace this bx term. So we're going to have 4x squared and 3, but in place of the bx, we're going to replace that with the 2 numbers that we just found, 4x and 3x. Notice this is actually going to be 7x if I were to combine like terms, but I want to not combine like terms. The reason I don't want to combine like terms is look, now I have a 4-term polynomial without combining like terms. So what I can do now, let's just erase this red so we don't get confused. So what I'm going to do now is I'm going to group it. I'm going to take my first 2 and my last 2, keeping the signs together. Out of my first 2, I'm going to pull out my greatest common factor, which is 4x. That leaves me with x plus 1. And out of my second grouping, I can take out a positive 3, which leaves me with x plus 1. Look at this. They're the same. So the x plus 1 that we just had, the same factor, we pull that out. And what I'm left with, I'm going to put in my parentheses as 4x plus 3. So we can use this for factoring trinomials too. So if you don't like the organization of the box, this is very similar, just in a different format. If we would have used the box method, the xbox method, we would have started by putting a 4x squared here in the top left and a 3 in the bottom right. Then we would have gone over to our x factor and noticed that we got 4 and 3, so 4x and 3x. And then we would have taken a common factor out of each row and each column. And we would have been left with x plus 1 and 4x plus 3. So using grouping is another way that we can factor trinomials. But the primary use you'll probably see it for is when we have 4 terms. All right, you guys have a great day.